All right, today we are going to start by doing some mental math, and then afterwards you're going to watch a video about adding and subtracting fractions with like denominators. You will do some problems on your whiteboard, and then at the end you'll need to get a sheet from the Unit 7 bin. You won't be doing the sheets in the actual math journal, but you will be doing your math boxes in your math journal. So we're going to start by doing some mental math. 1/6 of 30, 1/8 of 48, and 1/7 of 56. You can do this in two ways, remember. You can either make 6 boxes for this denominator, and 6 times what is 30? Well, that would be 5. So I would put 5 in all of the boxes. 5, 10, 15, 20, 25, 30. And then I look at my numerator to determine how many I'm looking at. Just 1. And in just 1 is 5. I can also do this by saying, what times 6 is 30? Well, 6 times 5 is 30. And then I need how many 5s? Just 1. So what times 8 is 48? Well, 6 times 8 is 48. And how many 6s do I need? Just 1. Try this one on your own. What times 7 is 56? And then multiply that by 1, or how many do you need? 8. 7 times 8 is 56, and I need just 1/8. All right, try these. Pause your video and then come on back. All right, what times 6 is 30? Well, that's 5. And how many 5s do I need? I need 5 5s. 5 5s, 5, 10, 15, 20, 25 is 25. What times 8 is 48? That'd be 6. How many 6s do I need? 5 6s. 5, 10, 15, 20, 25, 30. And what times 7 is 56? That would be 8. How many 8s do I need? 4. So that would be 32. Last group. Oh, this has the numerator that's a little bigger. Don't let that scare you. Pause your video. Work these problems. All right. What times 6 is 30? That's 5, and I need 9 5s. Well, 9 times 5 is 45. What times 8 is 48? I need 6, and I need 10 6s. Well, 10 6s would be 60. And what times 7 is 56? Well, that would be 8. And 8 times 11, or 11/8, would be 88. Today we're going to work on adding and subtracting fractions with like denominators. So 1/6 and 3/6 have the same denominator. You're going to watch a video to learn this concept, and then we will come back together.
Mathematicians, in this lesson, you will learn how to add and subtract fractions with like denominators by recognizing that the addition or subtraction of fractions is the addition or subtraction of pieces counted, but not of the pieces in the whole. You already know that one of the ways to express a non-unit fraction is to break it into its component parts. For example, 5 6 can be broken down into 5 1/6 pieces because putting 5 1/6 size pieces together will yield an amount that is the same value of 5 6. If I look at my picture, I see that I have 5 6 shaded in here and 5 1/6 pieces. The 5 pieces should fit perfectly on top of the 5 6 I've shaded. This shows me that adding 1/6 5 times is the same value as 5 6. This knowledge will help you add and subtract non-unit fractions because it will allow you to think about addition and subtraction as the putting together or breaking apart of fractions into sets of other non-unit fractions. Let's say I eat 2/6 of a pizza and my friend eats 1/6 of a pizza. I would like to know how much pizza we ate together. I am adding because I'm putting values together. Adding is counting up from one value to the next. My numerator tells me how many pieces to count, while my denominator tells me how many pieces there are in one whole. I remembered a minute ago that I can put together pieces of unit fractions to make non-unit fractions of equivalent values, and the same thing is true here. Thinking about my pizza, I realized that if I ate 2 pieces and my friend ate 1 piece, then together we must have eaten 3 pieces. That means I should add my numerators together when I add fractions. The denominator of 6 is a little different. Remember that 6 tells me how many pieces there are in a whole pizza. Just because I ate some pizza and my friend ate some pizza does not mean that the number of pieces in our pizza changed. Taking pieces of pizza out of the pan just means that more pieces are gone, but not the number of pieces that there were when the pizza was full differed. That means that when I add fractions, my denominator should not change. When I ate 2 6 and my friend ate 1 6, my friend and I ate 3 out of the 6 pieces that there were in the pan, or we ate 3/6 of the pizza together. I do the same thing for subtraction. Let's say that instead of wanting to know how much pizza we ate together, I want to know how much more pizza I ate than my friend. I am subtracting because I want to know the difference between values. Again, I know that my numerator tells me the number of pieces I want to count. So when I ate 2 6 of the pizza, I counted or ate 2 pieces. And when my friend ate 1 6, she counted or ate 1 piece. The difference between 2 and 1 is 1, so 1 is my numerator. Just like before, even though I ate 1 more piece than my friend, it does not mean that the number of pieces in our whole pizza changed, or that our denominator should change. I ate 1 more 1/6 size piece than my friend. Therefore, I don't subtract my denominators either. In addition and subtraction with fractions, I add or subtract my numerators because they tell me what to count, but I do not add or subtract my denominators because the number of pieces it takes to make a whole does not change. Let's try this in a problem. Michaela ate 7/12 of her orange before lunch and 4/12 of her orange after lunch. How much of her orange did she eat? I know I want to add here because Michaela ate some orange before lunch and ate some more after lunch, and I want to put the amount she ate together to see her total amount eaten. If I think about eating an orange, I realize that if Michaela started with 12 pieces in her orange, it doesn't matter how much she ate. She would still only have 12 pieces in the whole thing. This reminds me that I will not add my denominator when I operate. It will stay at 12 no matter what my numerator becomes. My numerators are a different story. Michaela started by eating 7/12 of her orange. 1, 2, 3, 4, 5, 6, 7. And then she ate 4 more of the 12 pieces. 1, 2, 3, 4. In all, Michaela ate 7 plus 4, or 11 pieces of her orange. Michaela ate 11/12 and had only 1/12 of her orange left. You just learned how to add and subtract fractions with like denominators by recognizing that the addition or subtraction of fractions is the addition or subtraction of the pieces counted, or the numerator, but not of the pieces in the whole, or the denominator.
All right, so we are going to practice this. You need your whiteboard with you. So let's do 1/6 plus 3/6. Remember, just like she said, the denominators are always going to stay the same when they are alike. So 6 plus 6 would not be 12. We would want those denominators to stay the same because we're working with the same whole. 1/6 and 3/6 is working with a whole of 6. So we're just adding our numerators. 1 plus 3 is 4. And then we are going to keep our denominator the same. 4/6, though, could be reduced to 2/3 because 4 divided by 2 is 2 and 6 divided by 2 is 3. We call this reducing, and this is now in the lowest terms. It can't get any smaller. Again, we did not add the denominators because the denominator is all of the same unit. It's one of the whole. So this whole would be 6. One part would be 1/6 and the other part would be 3/6. So I'm adding that together for 4/6. Try this one. All right. Again, we do not add the denominators as long as they are the same. We are going to add the numerators. 1 plus 1 is 2, so we have 2/3. This only works if the denominators are the same. If the denominators are different, there's a different process that we will use. You will learn that process tomorrow. Let's try some subtraction. Again, the denominators are the same, so I do not subtract those denominators and get 0. I'm instead only going to subtract my numerators. 5 minus 2 is 3, and 6 stays the same, so I have 3/6, and I can write that into lowest terms of 1/2, because 3 divided by 3 is 1, and 6 divided by 3 is 2. Both of these answers are correct. This 1/2 is just in lowest terms because we reduced it. You're going to work on this page today. Notice that all the denominators are the same, so therefore you're only going to be adding or subtracting the numerators. You could even put the denominator right over in all of these problems to make sure that you don't add or subtract the denominator. The denominator in all of these problems, one more time, is going to stay the same. You are just worried about the numerator. So in this problem, it's an addition problem. 2 plus 5 equals 7. Some of these problems will not be in lowest terms, so you might need to figure that out to solve some of the problems from above. For example, 11 minus 1 is 10. Well, I know that 10 divided by 2 is 5, and 12 divided by 2 is 6. So this in lowest terms would be 5/6, and I bet you my answer, which I cut off accidentally up here, will be up here in lowest terms. So you need to find a number that both of them have in common. That would be the 2, and then that would make it lowest terms. After you're done with this, you're going to be doing math boxes, but this is the only thing you're going to be doing in your math journal today. Good luck.